Okay, this is section 4.1, coordinates and scatter plots. We're going to plot points in coordinate plane. We're going to draw scatter plots and make predictions about real life situations. First definition we have is a coordinate plane. Coordinate plane is formed by two real number lines that intersect at a right angle. Simple coordinate plane would look something like this. Two real number lines that intersect at right angles. There are certain parts that you've been familiar with from other classes. We'll just quickly go over all of those real quick. Um, where the two lines meet in the middle, that value is 0, 0. That is known as the origin. The origin. Okay. Some people get which axis is which one is confused, the x and the y axis. Um, an easy way that we always go over to try to remember is if you take a look at the top of the one going up and down, you can do something like this. You can make it look like a big capital Y. The one going up and down, your vertical axis is your Y axis. Your horizontal axis, the one going across, is your X axis. So this is your X axis here, and your Y axis is the one going up and down. As numbers go to the left, they get smaller. Your negative numbers are on that side of the Y axis. And as they go to the right, they get larger. They're positive on that side. As they come above the x-axis, when you're talking about the y-axis, they get positive, and as it goes below, they get negative. Another part of coordinate planes that people sometimes get confused are what's known as quadrants. Again, this is something I think that's introduced to you all the way as back as far as the 6th grade. Um, Quadrants are always labeled in Roman numerals, and they're from 1 through 4. So your first quadrant is where it's Roman numeral 1 right here. It's where both your x value and your y value are both positive. So it will be positive, positive, and we'll look at what ordered pairs are in just a second. It goes counterclockwise, meaning it starts in this quadrant and it's going to move instead of going down. We're actually going to go to the left to go to quadrant number 2. Quadrant number 2's values are negative as you look at the x value, and positive as you look at the y value. So it's negative then positive. Then from there it goes down to quadrant number 3, where both of your values, your x and your y, are negative. And then finally you finish up in quadrant 4, IV, again Roman numerals, IV, where your x value is positive and your y value is negative. So those are quadrants in your coordinate plane. Next definition we have is that of an ordered pair. An ordered pair is each point in the coordinate plane corresponds to an ordered pair of real numbers. Ordered pairs are always written like so, x, comma, y. Um, Notice x always comes before y. Alphabetically, A, B, C, D, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, then Y, then Z. So just think of alphabetical order. X always comes first. Um, and X is how many times it goes to the left and the right. Y is how many times it goes up or down. So as you're looking at your ordered pair, X and right and up and down. Your x coordinate, again, is the first one in the ordered pair. So as you're looking at an ordered pair, x comma y, for example, might be 2 comma 3. Your x value is the one that comes, it's always the first one. So 2 would be your x value. 2 would be your x value. That tells you, since it's positive, that tells you that you go to the right, because positive numbers are to the right, 2 times. So as you're looking at plotting on a coordinate plane, it looks something like this. You always begin at the origin. This tells you directions. This tells you to go to the right from the origin 2 times. So from that 0, 0 origin, you go to the right 2 times. That's what it tells you to go to that spot right there. Then the x value is to go to the right 2 times, the y value is going to tell you to go up 3 times from there. So if you're looking a little further into this one, we'll look at the y coordinate in just a second. This one tells you to go up 3 times. So from there, you go up once, then twice, then 3 times. So we go to the right twice, and then up once, twice, 3 times, and that's where our plot would be according to this example here. Again, y coordinate tells you to either go up or down. X coordinate told you to go left or right. This is the one that is the second number in the ordered pair. This one tells you up or down. If you go up, it'll have a positive number. We'll tell you to go up. If you're going down, it'll have a negative number. Go back to the last one a second ago. Your x coordinate, it'll either tell you to go to the right or to the left. If it tells you to go to the right, it'll be a positive number, and to the left will be a negative number. The graph is the point in the plane that corresponds to an ordered pair. So if you're looking at the same one that we just said a second ago, 2, 3, 0.23, okay? That is your x value, then your y value. 2 tells you to go to the right 2 times, and it tells you to go up 3 times. So if we graph that according to this, we'd go to the right twice and up 3 times. The graph of this is that point right there, 2, 3. That is the graph. We always say graph it, but in actuality, you're plotting that point. You're plotting the graph. This is the graph of it, 2, 3. And then a scatter plot is a graph of pairs of numbers that represent real life situations. It's an easy way to analyze the relationship between two quantities. And we'll look at a couple of examples of those in just a few minutes. Okay, here's example number 1. You're plotting A, B, and C, and they give you 3 different values of A, B, and C. The first one, -2, is, remember, it's always your x value followed by your y value. -2 tells you to go to the left 2 times. Y tells you to go up 3 times. So your first one, -2, 3, you start off at the origin and you go to the left 2 times, once, twice, and up 3 times, once, twice, 3 times, and that's why we have a plot there. Your second point, 3, -4, B, tells you to go to the right 3 times and to go down 4 times. So to the right, again, start at the origin and go to the right once, twice, 3 times, and down 1, 2, 3, 4 times. And then finish off with your last one, 0, -2. Again, your x value, comma, your y value, or your x first, then your y value. X tells you you don't go to the right or to the left at all since it's 0. Y tells you to go down since it's -2 times. So again, starting at origin, going down once, twice for your second point right there. And I know I used red, black, and blue. It's where you can see it a little bit differently where each of the 3 are. Here's the checkpoint. I told you to plot these 4 points. I'm not really sure why they plotted them for you, but you can see where each of them go. The first one, point A, is -3, -2. It's always x, then comma y. So x tells you to go left 3 times and down twice. So again, you always start at the origin. You go to the left 1, 2, 3 times and down once, twice. And you can see your point right there. Your second one, again, it's x, comma, y. It tells you to go to the right 4 times and not up or down at all. So to the right, you start at the origin, 1, 2, 3, 4, right there, not up or down at all. The third one, 1, 4, tells you to go to the right 4 times and up 4 times. So again, starting at the origin, 1 time, and then up 1, 2, 3, 4 times for that one. And then the last one, we use red again. Tells you to, it's x, comma, y, tells you to go to the left 3 times and up 2 times, starting at the origin, to the left 1, 2, 3 times, and up once, twice for that last one. value point should be. Okay, and then example number two is NCAA basketball teams. It says since 1995, and they show 96, 7, 8, 9, and 2000, how many basketball teams they have. They tell you to draw a scatter plot of the data and then describe the pattern of the number of men's basketball teams. Um, Again, I noticed a lot of you guys were drawing scatter plots off to the side. That's great. Not really sure why they drew the scatter plot for you. What's actually down here is the scatter plot that it says. It says let M represent the number of men's teams, so M for men's teams, and T represent the number of years since 1995. So T is representing time in this case. Because you want to see how the number of teams changed over time, put T on the horizontal axis. Horizontal, that word horizontal has the word horizon in it. Horizon. Think of looking out on a horizon, um, like looking out across like a plane or out on sea or something like that. If you ever get confused between horizon or the horizontal and the vertical. It's on the horizontal axis, and M is on the vertical axis. Choose a scale, use a break, and when they say break, they mean this little symbol right here, everybody. That just means it's broken from 0 to 800, so it's not showing anything between 0 and 800. To focus on values between 800 and 950, since you didn't go above 950 with teams. Your scatter plot should look something like this. In the first year, so years since 1995, this is saying 1995 right here. So it's 0, had 868 or whatever the number was. I have to look back a second. 868. Then it actually went down a couple of years. Notice it goes down just a little bit here and then a little bit further here until it starts to go back up again in 1998, up a little higher in 99 and in 2000. It's at its maximum according to this chart, which is 932. And then finally, the last part says from the scatter plot, you can see that the number of men's basketball teams in the NCAA was fairly constant for 3 years. It went down a little bit, but it was almost the same number of teams, and then it began to increase gradually, going up. If you wrote something slightly different from what's up there, but you have the same general meaning, you don't need to change it. Everybody, these are your words to best describe what's going on.